Hello everyone, welcome to today's session. In this session, we are going to do a topic called we're going to do this topic called mass and weight. Basically that. So we've all been to a hospital or maybe a clinic, and they had to measure our body mass or maybe our body weight. Or we've taken maybe children to what is called under 5 clinic, and they had to measure their weight or maybe their mass. Now, what is mass and what is weight? This is what we are going to explain in this video. Okay, so stay tuned as we discuss what mass is and what weight is and the differences between mass and weight. And we're going to do, or to cover rather, the units used to measure mass and the units used to measure weight. And we're going also to explore the instruments which are used in measuring mass and in measuring weight. So let's begin by defining what mass is and what weight is. So what is mass? So let's begin with mass. So mass is simply the amount of matter contained in a substance. So it is simply the amount of matter in a substance. So we know that matter, this is a common term. Most of us have used it before. Matter. Okay, we use it maybe in grammatical expression, like something is bothering you and someone asks you what's the matter. Okay, but this matter we are talking about is just the amount of space. Okay, and anything that has mass. Okay, so anything that has mass and occupies space, that is the matter we are dealing with in this topic. So we've defined what mass is. Let's understand what weight is. So when you're dealing with weight is simply the pull of gravity. Okay, the pull of gravity on an object, that is weight. If you throw maybe a ball in the sky, or you throw a ball maybe in the atmosphere, okay, the ball usually comes back. If it comes back, then there's something wrong with it. Okay, but it has to come back due to the pull of gravity. That is gravity, which pulls everything towards the center of earth. The force that pulls everything towards the center of earth, that is the force of gravity. So when you're talking about weight, we're simply talking about the pull of gravity on an object. Okay, so what is weight? Weight is simply the pull of gravity on an object. Okay, now let's understand something here. Let's understand the units. Okay, so we have mass here, then we'll have, let's say, weight here. Okay, so most of us confuses the difference between weight and mass. You may be wondering why. Okay, or maybe you can just say, maybe I went to the clinic and they got the weight was 2 kg. Okay, I weighed 2 kg. Or maybe let me not even say 2 kg because that is still small. Or maybe let's say I weighed maybe 50 kg. Okay, but you are using a correct figure in a wrong contexture. Okay, you are using it in a wrong way. But let's try to understand it and be able to correct ourselves. Okay, so this is basically what us, or what we are able to learn, okay, this is what we are going to learn in this, so that we reduce on the misconceptions and use of these terms, like wrong use of these terms. Okay, so let's understand something so that you're able to use the right units for the right for the right context. Okay, so what are the units for mass? So we are talking about the SI unit here. Okay, the SI unit. So mass is measured in kilograms. Weight is measured in newtons. The symbol for kilograms is kg. The symbol for newton is just capital letter N. But there are simply other units which are used to measure weight and mass. There are simply other units, in fact, which are used to measure mass. Okay? For weight, it is simply, if it is not a newton, because a newton is just a newton is equivalent to a kg, meter it is a kg, like that, per square meter. Okay, that is a newton. So basically you can use that or just a newton, but mass has a lot of units, so you can use grams, which are written as G. Other than that, maybe you can use other units like milligrams. Maybe we can use other units like tons. Okay, we've heard of, maybe this sand weighs 100 tons. Okay, you can use tons. You can also use kilograms, which are written as kg or denoted as kg. We've heard of 25 kg of meal, 2 kg of sugar, and all of that. Okay, so this is basically about the units. Now let's look at the instruments. Instruments. We are looking at the instruments which are used to measure mass and those which are used to measure weight. So to measure mass, you can use what is known as a beam balance. Okay, a beam balance, as the name suggests, there will be a certain weight here, okay, and another weight there, then like that. So this is a weight, maybe let's say 20 kg, and this is another weight. Okay, so this is how a beam balance looks. Other than a beam balance, you can use what is known as an electronic balance. Okay, you can even use an electronic balance. For weight, you can use what is known as maybe a Newton meter, or you can use a spring balance. We've taken children to under 5 and they put them in a certain bag, then they weigh their weight on the spring balance. Okay, so that's a spring balance, the one they usually use for under 5 and all that. So on the mass we have the beam balance. We can even use the electronic balance, okay, and other balances, of course. So let's understand now the difference between mass and weight. Let's understand the differences. So we have mass here, we have weight. So the difference, one of the difference lies in the definition. We said mass, amount of matter. That's one difference we noted. But weight is just the pull of gravity. Okay? Then the second difference we can talk about is the way these things are. You need to know that mass is constant, okay? Mass is constant. If you go to moon, then let's say you weigh 50 kg. You weigh 50 kg. If you go to moon, you still weigh 50 kg. If you're on Mars, you still weigh, if you go to Mars, you still weigh 50 kg. If you go to Earth, you're on Earth, it will still be 50 kg. Mass does not change. Okay? Then let's look at weight. Weight, we're going to say, changes depending on location. Okay, so that's another difference. That's a difference, mass and weight. So this one is not affected by gravity. Mass is not affected by gravity. Weight is affected by gravity. It is affected by force of gravity. Then, upon appreciating that concept, let's look at an example. Let's say a man weighs 40 kg. Okay, a man weighs 40 kg. Calculate his weight on Earth. Okay, calculate his weight on Earth. So they usually put the gravitational force you need to take. So in this case, let's say take the gravity on Earth is somewhere 9.98. Okay, or let's say the gravity is 10 meters per square second, like that, but it is taken as 9 point something. Okay, that's the gravity on Earth. Okay, so how can you calculate this particular equation? So you need to know that to calculate weight is simply the mass times gravity. So the man weighs 40 kg, the gravity is that one. Let's calculate it. So the relationship between mass and weight is that weight is equal to mass times gravity. But this weight is basically symbolized as Fg. Fg is equal to mass times gravity, because Fg, that is the force of gravity, which is simply the weight. Okay, let's now try to understand this and answer this question. So we write the formula: weight is equal to mass times gravity. So weight will be equal to, the mass we've been given is 40 kg. The gravity we have is, it is 9 point, okay, it was 10 meters per square second. So weight will be equal to 10 multiplied by 40, that is 400. Weight we said is measured in newtons, so that's how you can calculate the weight. Okay, so let's look at another example. Maybe a man, a woman, let's not just stick to men. A woman weighs 60. Okay, 60 kg. Then, yes, 60 kg. Or maybe let's say, okay, let's say maybe 60,000 grams. Okay, calculate. The first question is his weight on Earth. Question B, his weight on Moon. Then question C, let me write it here. Calculate his mass on Moon. So these are the questions we have. Let me just go to the next slide. Okay, so these are the questions we have. So the first question, calculate his weight on Earth. So we apply the formula. We know weight is equal to mass times gravity. So weight will be equal to, what is the mass? The mass we've been given is 60, is it 60,000? Yes, 60,000. But you need to convert this mass into what? Into kilograms, the SI unit for weight, for mass rather. Okay, so what you need to do basically here is this. So you know that 1 kilogram is equivalent to what? 1,000 grams. What if we have 60,000 grams? What will be in the value in kilograms? So you say simply x there. We don't know, so that's what we are finding. So we're going to cross multiply. So x by 1,000 grams, we're going to say x, okay, x multiplied by 1,000 grams is equal to 1 kg multiplied by 60,000. Let me get rid of this. So to find the value of x, we're going to divide on both sides by 1,000 grams, even here by 1,000 grams. So 1,000 grams and 1,000 grams, we're going to remain with x is equal to, grams and grams will cancel. So we're going to say 0, 0, 0, 3 zeros, we cancel 3 zeros on top, also 1, 2, 3. We're going to remain with 60 by 1 kg. So we'll have 60 kg. So 60 kg is the mass. We've converted this mass. So always make sure that you convert the units to their SI units. Mass, the SI unit is kilograms. Then let's now calculate the weight. So weight is equal to mass times gravity. Mind you, we are talking about gravity on Earth. Gravity on Earth, okay? Gravity on Earth is somewhere 9 point somewhere there. So 9 point something. So let's just take as 10 because sometimes it's just taken as 10 meters per square second. That's the acceleration due to gravity. So mass is 60 kg. We're calculating weight multiplied by 10 meters per square second. So our weight will be equal to 60 times 10, that is 600, and the units are newtons. So basically this is how you can calculate the weight, and this is on Earth. Then weight is equal to, this is question 2 now. Weight is equal to mass times gravity. So weight is equal to, we know that gravity on Earth, don't worry, it will be given, it is on Moon, it is somewhere 1.67 meters per square second, somewhere there. Okay, so the mass we have is 60 kg multiplied by the acceleration due to gravity. Now we are talking about Earth here. We have gone to Earth, so it will be 1.67 meters per square second. So weight will be equal, let me just use the calculator. Okay, so we have 60 multiplied by 1.67, so it's giving 100.2 newtons. So this is how you can calculate weight. So what's the next question now? The next question was C, calculate the mass on the Moon. In fact, this is a tricky question. This is a tricky question. Mass on the Moon. Remember we said mass is constant everywhere. Whether you're on the Earth, you're on the Moon, mass does not change. So there, you just say mass is equal to, what was the value given? 60,000. So mass is equal to 60,000 grams. Or this one, we converted it, you can say mass is equal to, let's say, 60, since we said it is equivalent to 60 kg. So basically that is how you can go about these problems, okay? So this is what you need to know about mass and weight. Thank you for watching. Have a wonderful day.